Now, write down the first 5 terms of the sequence formed by the reoccurrence equation. S0 equals 6, Sn equals 2 plus Sn minus 1. Is that alright with you guys? So, S0 is 6. What can we say S1 is then? What's S1? 2 plus what? S0, which is 2 plus. And what's 2 plus 6? 8. Is that alright? Next thing. What's S2? 2 plus S1. What's S1? And what's 2 plus 8? 10. And so forth. What's S3? 2 plus S2, which is 2 plus 10, which is 12. Is it just going up 2 every time? And S4? 2 plus 12 equals 14. Does everybody get that? It makes a sequence like this. 8. Do you know what the awkward part about this is? Instead of using Tn, they're using Sn. And Sn usually means something else, doesn't it? You could easily replace this full equation with T's instead. And it will do exactly the same thing. Don't know why they chose S. Just being incredibly awkward because S usually means something else. Okay? Now, it wants me to prove that it equals this here. What's the gap between every one? 2. Okay? So, and hence show that can be represented by this following linear equation. Okay, and what's the A value? The A value is 8. The N value. Alright, so Tn is 2 times N. And 2 times 1 would be, what's 2 times 1? 2. Are you too big or too small? You're too small. You need to add on a 6. Would most of you guys use, to do that, would most of you guys use the Tn formula? A plus n minus 1 times d, where a is 8 and d is 2. And you get 8 plus 2n minus 2, which is your 2n plus 6. That was pretty damn easy, wasn't it? Alright. Let's go to question 7. So please don't get mixed up with sum. It's just saying S represents sides, okay? So, for the number of triangles Tn plus 1 equals Tn plus 2, T1 equals 1. Alright. Yeah, the two of them aren't questions, are they? They're just stating facts. Does everybody agree with that? It doesn't ask me to prove that. Alright? If the pattern is continued using these relations, answer the following. Find T4. Okay, what do you think? Let's start off with T1. What's T1, lads? T1 is 1. What's T2? T2 is T1 plus 2. T3 is T2 plus 2. And T4 is, do we get the gist? And how high do I have to go up here? I have to go all the way up to 6 for my sins. Is that alright? So let's start off. What's T2 then? Go on. T2? T3? Just keep adding on 2, isn't it? What's T4? T5? And T6. Awesome. Alright. Let's start off with the S's now. Okay. What's S2 the same as? S1 plus 4. I think it's just going to jump up in 4s, do you? So what's S1? 3. What's S2? So S2 is 7. S3, S4, 15, what's it, 19 and 23. Done and done. The answer that I'm looking for is these ones here, which are this answer here. We all good? Alright. Show that each sequence is an arithmetic sequence. So what do we do there? We use the Tn formula. We don't actually use the Sn formula as it normally is. Why? Because Sn doesn't actually represent the sum of the series. All what it represents is how many sides there are. So what do we get for both of these then, lads? What's your A value for T? What's your D value? So what do we get? N plus 1. And, sorry, what'd you say? Yeah. And what's the other one? 3 plus 4n minus 4, which is 4n take away 1. Believe it or not, guys, I didn't actually answer part B. I actually sort of answered part C instead. How do you prove something's arithmetic, an arithmetic series again? Just show that the gap is always there. Just show the gap is always the same. That's what proves it's arithmetic. Is that okay? If the gap is always the same, it proves that it's an arithmetic sequence. Is that alright? My bad. And we've already answered part C, haven't we? Done. Find the number of sides in the 20th pattern. S20. S20 equals 4 times 20 take away 1 is 79. Alright, don't do them now, but equations for tonight are 2 4, 5 and 6 for tonight, lads. What ones did I do? 3 and 7. Alright.